Good morning everyone. So today I will be dealing with the topic variational principle. Okay. So first I will consider a function f such that f is defined on f is equal to f of y dot and x, where the y dot will be dy by dx. So this function f is defined on a curve which has a starting point a and final point b. It has coordinate x1, y1, and this has coordinate x2, y2. So here x1, x2, y1 and y2. Okay. So it is defined on a curve which has starting point a and ending point b. Okay. So as for the condition, this y, the function y dot and x, they are independent of each other. Okay. So going to the statement of the variation principle, the variational principle states that the line integral of I of the function f has a stationary value. That is, I is equal to the line integral from x1 y1 to x2 y2 f of y dot x has a stationary value. Okay, that is the statement of variational principle. Got the idea? The line integral I of the function f of, that is integral x1 y1 x2 y2 f of y dot x is equal to a stationary value. Okay, so by this principle we are going to derive a equation. Okay, so that is what we are going to learn here. Okay, so as I said here, we have a function f y dot x which is defined on a path y is equal to y of x between the two values x1 and x2, where y is the derivative of y with respect to x. Okay, so now I will consider here considering the path between these points. So one path will be it will be a straight line, and while another path will be a curved path. A maximum number of path can be drawn between the starting point and end point, right? We can draw a maximum number of paths. But here I am only considering two paths, which is A and representing the straight line with P, and the curved path with P dash. Okay. So we have two paths here, which are the APB and A dash and B. Okay. So as we can you say that which will take the minimum time here? Which path will be taken? APB. Yes, APB will take the minimum time here. Okay, so how that can we derive that later? Okay, so by your common sense we can say that which will take the minimum time. The path APB will take the minimum time. Okay, so now with the path APB, we are considering the value of I as stationary value. That is the variational principle. We are applying the variational principle there. So now what I am going to do is we are drawing a perpendicular line along the x-axis. So it will be ax and y. So the path from here to here, this will be changing by, while this small distance will be del plus changing delta y plus delta. Okay, so what I am going to do is I am going to write changing dou y by dou alpha into delta alpha. That is del y is equal to dou y by dou alpha into del alpha. Okay. So here alpha means it is a parameter which is representing a particular path. For example, there is a corresponding alpha in the path A, P, B, while there is a corresponding alpha in the path A, P dash B. But this both alpha will be different. So the alpha is a parameter which is in a particular path. Okay. So it is a alpha representing a particular path. Alpha is a parameter which is representing a particular path. Okay. So now what we are going to do is we are giving this value. When we represent that here, what we will get? Delta y is equal to eta of x, delta, right? So now what I am going to do is I am going to find the derivative of this. So I will rub this figure. By finding the derivative of that, delta y dot is equal to dou y dot by x into del alpha, that is dou by dou alpha into dou y by dou x into del alpha, that is if I interchange it, dou by dou x del y by del alpha into dou alpha into del alpha. So this is eta x. So dou by dou x of eta x dot del alpha. Okay. You got the idea? So then we can write del alpha dot is equal to eta x dot del alpha. Okay. So now what we are going to do is we are considering the path A, P, B. Okay. Considering the integral of the path A, P, B. I am writing this side. So for the path A, P, B, I is equal to integral x1, y1, x2, y2, f of y dot x dx. And for path A, P dash B, I dash is equal to integral of x1, y1, x2, y2, f of y plus del y plus y dot plus del dot y plus x dx. Okay. So what we are going to do is we are taking y dash and x in one side. So we get integral of x1 y1 x2 y2 f of y dot x plus dou f by dou y del y plus dou f by dou y dou del y dot into dx. Okay. Any doubt? So now we will separate the integral to each term. So we will get integral x1 y1 x2 y2 f of y dot x dx plus, can you say, separate the integral to each term. Integral of x1 y1 x2 y2
dou f by
dou f by
dou y
dou y
into delta y.
Del y dx plus integral of x1 by 1 x2 by 2
Dou f by dou y.
dou f by dou by dot del by dot dx. Okay. Okay then. So this term is what? What is this term?
A.
I. Okay. So we will get I dash is equal to I plus this term. Okay. I plus integral
x1 y1.
So in the previous I wrote that del y is equal to eta of x del alpha, right? So here we can substitute this term, right?
Yes.
In the term of del y. So we write x1 y1
x2
x2 y2
dou f
dou
by
f
dou
by
y.
dou y
Eta x.
eta of x okay plus
Integral
same thing. If it is derivative, so we get
Eta dot x.
right? So that is
integral x1 y1.
integral x1 y1 x2 y2
Dou f by
dou f by dou y dot eta of del alpha into dx. Understood? So what we are going to do is we are taking this part alone and we are doing the integration by parts in this part. Okay. So integral of x1 y1 x2 y2 dou f by
dou y dot
dou y dot
eta dot x.
eta of x dot del alpha dx is equal to dou f by dou y dot eta x x1 y1 x2 y2 minus integral of x1 y1 x2 y2 d by dx of dou f by dou y dot eta x dx into del alpha. We are doing the integration by parts in that. Okay. So integral of x1 y1 x2 y2 dou f by dou y dot eta x dot del alpha into dx is equal to dou f by dou y dot eta x upper lower limit x1 y1 to x2 y2 minus integral of x1 y1 x2 y2 d by dx dou f by dou y dot eta x dx into del alpha. Okay. So so the upper limit and lower limit of eta of x1 and eta of x2 will be 0. So what we will do is we will cancel this term. Eta of x1 and x2 will be 0. So when we do this, this term will be 0, right? So what we will do is we will cancel this term and we will write the remaining thing. So the remaining part will be integral x1 y1 x2 y2. This will be equal to minus of integral this. What did I do? Okay. Now I am not writing that again. So what we will do is we got what I dash is equal to I plus this plus minus this, right?
Yes.
Okay, so I will write that. I will take I to left hand side. So I dash minus I will be
Integral
integral of
x1 y1
x1 y1
x2 y2
x2 y2
dou f by dou
dou
y
f by
dou y
dou y
eta of x
eta of x
dx.
I will take the dx into the class. Dx minus integral of x1 by 1
x2 y2
x2 y2
d by dx of
d by dx of
dou f by dou y dot eta of x x dx.
So eta of x alpha into
dx.
Okay, so this will be what? This will be the change in time. Okay, right? The length. So this will be what according to the variational principle? According to variational principle, I said that integral of I of function will be has a stationary value. That is del I will be 0.
Zero.
Okay, that is according to variational principle. Okay, so this is what change in I. That will be equal to what?
Zero.
0 according to variational
Variational.
principle. Okay, so what I am going to do is I am writing the dou f terms together. Dou f by dou y terms together. So we get integral x1 by 1 x2 by 2
Dou f by
dou f by dou y minus d by dx dou f by dou y dou eta x del alpha dx. Okay. So according to this will be 0. That is, this will be what? 0 according to variational principle. Okay. So this and this will be 0. That is, this is a function of x and eta x is arbitrary. So this and this will be 0. So we are cancelling that. So what we will get? Remaining thing is we will get dou f by dou y minus d by dx of
dou f
dou
by dou
f
y
by
dot
dou by dou
dx is
is equal to 0. So and this here is so we get d by dx dou
dou
f
f
by
by dou y dot
dou f by dou y dot minus dou f by dou y is equal to 0. So any factorization is yes Lagrange, right? So this equation is known as Euler-Lagrange equation. Okay. Lagrange equation. What is going to the application of this equation? So first we will see the shortest distance between 2 points in a plane is a straight line. Okay. So now what we are going to do is we are considering a small portion ds for this part. Okay. So ds square is equal to dx square plus dy square. So what will be ds? Root of dx square plus dy square. So taking dx outside, dx 1 plus
d
this is dy by dx square. So dx root of 1 plus
y dot square
y dot square. This is ds. So now we are integrating to find s. Integral of from a to b ds. A coordinate is x1 y1 and b coordinate is
x2 y2
okay. So integral of x cube by 2. Dx is dx root of 1 plus y dot square. So this equation, it is similar to what? This equation is similar to our
x is to f of y dot
y dot x dx, right?
s.
dx. So what we take here? Function will be root of 1 plus
Y
y
dot
dot
square.
square. Okay. So now what we are going to do is we are substituting in this equation. Okay. So find what we have to find. First we have to find the y, that is 0. The y by the y dot. Y dot by root of 1 plus y dot square. Okay. Now we have to find dy dx of this, right? By that is 0.
Yes.
Clear?
Yes.
So we can say that this term is this, right? So we can say that y dot by root of 1 plus y dot square is equal to a constant, right? So y dot is equal to c into root of 1 plus y dot square. So y dot square is equal to c square into 1
plus
y
y
dot square. So y square minus c square
is equal to
y square is equal to c square.
yes.
This will be c square plus y dot square. And y dot square minus
C square y dot square is equal to c square.
So y dot square is equal to c square by 1 minus c square, which is another constant. So I am giving it as m square. So y dot square is equal to m square. So y dot is equal to m. So y dot is dy by dx, right? So y dot is equal to m. So dy by dx is equal to m. So dy is equal to m dx. So y is equal to mx plus
C.
c, which is the equation of a
Straight line.
That is the first application. Next is another. Next is a soft field problem. Please. What we have to find, what we have to do is we have to find the minimum surface
area.
So in this curve, if the starting point is A and then the point is B, and if a revolution is happening, it will be like this. Yes. It will be like this. So what we have to do is we have to find a minimum surface area where the revolution will be less. Okay, so that is what we have to find. So we have to find the minimum surface area where in this curve the minimum surface area will be there. Okay, so what we have to do is we have to take the small portion ds. It will be radius will be x. This point will be d dash and this point will be b. of this strip will be dA is equal to 2 pi x into dx. 2 pi into x. Area will be 2 pi x into dx. So dA will be 2 pi x root of dx square plus dy square. Is 2 pi x dx
1 plus
1 plus y dot square. dy by dx, so that will be y dot square. Okay. So total surface area A will be integral of A to B dA. This is integral of x1 y1 x2 y2 2 pi x dx 1 plus y dot square. So comparing to the equation I is equal to integral x1 y1 f of y dot x dx. What will be f here?
2 pi
Yes, remove 2 divided.
2 pi x root of
Yx
1 plus y dot square.
Okay.
So
So what we have to find? We have to substitute in this equation. So first we have to find y dot y
is equal to
0
0.
divided by y dot is equal to 1 by x into 1 by 2 root of 1 plus y dot square into 2
Right.
y dot. Okay,
2
so
into
if
cancels.
so we get that answer as
2 pi x
2 pi x
1 by root of
into y dot by
1 root of 1 plus y dot square.
y dot square. And d by dx of this will be 0. Okay. So substituting d by dx of this will be 0. So 2 pi x y dot by root of 1 plus y dot square will be a constant. So I am making it as a. Okay. So
I think that is not power.
x y dot square will be a square 1 plus y dot square and y dot square. So x square y dot square minus a square y dot square is equal to a square.
If we are improving that, we may also improve that.
It's
Okay.
So x square minus a square y dot square is equal to a square. So from this equation, what will be y dot square?
a square by x square minus a square.
Y dot square is equal to
A square by x square minus
s square minus a square. So y dot is equal to
root of
a by root of
x
x square minus
a square.
a square. So this is what dy by dx. So dy is equal to a by root of x square minus a square into
dx.
dx. So y will be a into integral of dx by root of x square minus a square. So that is the integral of that will be y is equal to a into cos x inverse x by a plus b. So y minus a by b is equal to
cos
cos
x
x
inverse
inverse
x by
x by
a.
Y minus b by a, right?
Y minus
so x by a is equal to cos x y minus b by a. So x is equal to a cos x y minus b by a, which is the equation of Cartesian. So we can say that the curve is a U-shaped curve. So we are getting the minimum surface area. Okay. So that's what.